Okay, so today we're going to talk about Terraform. I decided to host my service on Amazon Web Services, AWS, cloud provider. I use Terraform so that I can, define what it is I want the system to look like, and then I can go back and destroy it later, so that I don't have to pay for it when I'm not using it. So I have a full description of all the things that I'm creating on the cloud platform, and I can change that description, recreate it, and refine it until it's the way I like it. And so the nice thing about Terraform is that it's a declarative language, which means that you say what it is you want, and it looks at what's out there and compares the difference and says, okay, this is what I need to do to create those resources. So the way we use Terraform is that we first install it, then you install the AWS CLI. We need to go into AWS IAM and create a CLI key, which I've already done. And then you got to go back onto your command line and type in AWS configure. You enter in the key and the password that you just created up in AWS. Put in your default region, US East 2 in my case, which is Ohio, and then JSON for the format. Then you type in Terraform init to set up your local environment so that it has all of the compiled resources you need locally so that you can talk to AWS. Then you validate your script, which you just created. I have a rather extensive script, which you'll see later. And then you run the apply and hit yes to actually run the application of those changes to your environment. And then when you're all done, you hit Terraform destroy. If you are going to go back and use it again, you may not want to destroy the whole thing. You might want to just turn off the database and the ECS service where most of the cost comes from, and then just kind of come back to it later, because it's pretty scorched earth to be fully creating and destroying every time you want to use it. So my advice on using Terraform that I found is try to remove any repetition. You don't want to do copy and paste too much. You want to use your dry principle and use a for each over an array that you pass in. Also think about your dependencies. You may need to explicitly define a dependency here and there to make sure things are created in the correct order. For me, the hard part is the system design. I don't even know what I should be asking for a lot of the time. So I have to really think that through, and it really reveals any weaknesses that I have in understanding AWS and in system design in general. It's it makes me really up my game to say that I have to come up with all the descriptions. So let me just also say that for networking, that's just not my strong suit. So I found a good video from Travis Media I'd recommend on network overview for AWS. It was a good course. Oh, then one other piece of advice here is that when you're making your cert, make sure it's a wildcard cert, because that's not going to work if you're going to be using a subdomain that's something other than, say, familysanta.com. You're going to need star.familysanta.com in order to use one of your subdomains. Okay, so now that we have this advice done, let's go take a look at what I've done so far. I did actually run the Terraform init and the validate, and I'm about to run the apply. So what it will do is actually going to go out and compare what's out on my AWS account with what I wrote in that script. It takes a little while because there's a lot of code in there. Okay, 73 items. Yes, I want to run that. All right, so while it's doing that, let's talk about the system design. So I manually went out to GoDaddy and registered my DNS. I pointed that DNS name over to AWS Route 53, which I already set up manually. I set the one A record to point actually two A records, to point to Bluehost, and MX record to point to Bluehost as well. Set up the email. There's another video on this. I registered a container definition for Family Santa. In another video, I showed that I did a Node.js Express app, and which talks to RDS and uses secrets, and I since then have created a Docker container, which I'll review at the end here. And so then, in order to upload that container and put that into ECR, I run through this process here. I'm building it, I'm tagging it, and then I'm pushing it. And this account number here is the number for my AWS account. So then in Terraform, I'm going to be creating a VPC, internet gateway, 9 subnets. I have 3 subnet groups: public, database, and app, and then I'm using 3 availability zones. That's how I get to 9. So there's 3 route tables, one for each of my subnet groups, and then I have to make an association between each of those subnets into the route tables. And there's 2 egress routes for the internet gateway, the public and the database. I want the database one to be on the public side because I want to be able to access the database from my home, which I'll do in a little bit here. And so a lot of designs you wouldn't do that, but I'm just saying in this case I am. And then there's an elastic IP pointed at the NAT gateway, and a default route so that the app subnet can get out on the internet. And then I make security groups for each of those. So I have an RDS instance that's holding the MySQL database that I created. Route 53 record for db.familysanta.com that points to that database. Then for ECS, I have a cluster that's defined to use Fargate, which means I'm using their computers, not my computers. I don't want to define any computers. Let them do that. Let them manage that. So, and then I have a single service called Family Santa, just called Family Santa. Auto-scaling target, 2 auto-scaling definitions, so that it will scale up or down based on the amount of CPU and memory being used. Then there's a task definition that's defined that points to that container in ECR that I mentioned. Then there's a CloudWatch group so that anything in the task definition is logging to that CloudWatch group. There's an execution role for creating the task and a ECS runner role for the task itself. Then there's an Elastic Load Balancer target group that points to all these ECS instances. And then there's a application load balancer with a rerouter so that anything HTTPS that comes in is routed over to HTTP, and then HTTP is pointed over to the target group. Then there's a SSL certificate with DNS verification, which means that there's another record in the DNS that verifies that it is indeed my certificate. And that's all created, pointed to this Elastic Load Balancer. Okay, so then I need to make some secrets for Family Santa DB and Family Santa credentials, one for dev and one for prod. And this is a good point here. I found this out the hard way. Make sure that your database URL is not db.familysanta.com. That only works externally. Internally, you have to use the internal name for that database instance. And then I'm going to run the setup SQL and the init SQL scripts so that I get a working database on that server. And then anytime that I need to reforce a release, this is the code that I use for that. So we'll just skip to the end here. And then we'll test it. All right, that's finally completed. So we're going to grab the SQL code. Okay, let's give this a try. So here's the script for creating the database. Of course, the ECS task, the Docker task, the Node.js app doesn't run without the database, so I got to get that set up. And so I'll run this, and then I'll run the init, which has some of the secrets in it, and then I'll get back to you. All right, so that's set up. Let's go into ECS real quick and make sure we have a task running. It's quite possible that it's not running because I didn't get the database up and running. Yeah, no tasks are running. So let's get that running again. Or maybe I should run that script to force the rerun. Let's do that. So I'm going to run this script to force another release. So I don't want to destroy it quite yet, do I? Update the service. Yep, that's it. Let's go take a look at ECS and see that it's actually running. It's getting there. Pending. Activating. Okay, getting close. Okay, it's running now. Great. So I go over to CloudWatch. Look at the most recent log. Config info received, blah, 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 blah. Connection, service ready. We created a database connection. Good. All right, so we can go in and log into app.familysanta.com. Yes, we're logged in. You can tell because it blanks the screen, I don't actually have anything to look at yet, but it does work. So we can go in here and to CloudWatch and get the most recent entry and see that there's some traffic in here. Service ready. I'm getting a default route index and then the code. Okay, away it goes. Takes a while, but trust me, it'll complete. We'll let that go. So I just wanted to go through what the cost breakdown is. We got the $625 per day breaks down into a little under $4 per day for the database, $150 for EC2 other, whatever that is. I guess it's just the gateways. I'm not sure if there's some other things in there. Then there's Elastic Load Balancer, 50 cents a day, 30 cents a day for the ECS service, which is just 1/4 of a CPU container that's running, and that's enough for our purposes. And for this simple app. And then pretty much all those other things, they amount to about nothing on a daily basis. Over time, CloudWatch will start to cost something because it's basically it's charging for the amount of memory that I'm using, amount of storage. And right now there's nothing in there, but over time there'll be more and more in there. The secrets, I hardly ever use them. I forget what it is. It's like 10,000 calls for a penny or something silly like that. So basically, it's basically free. However, I do have a Route 53. I forget what you call it, but basically, I'm hosting that name there, and that's 50 cents a month. So there's some cost that's more than just per day. And schedule-wise, I am still on schedule. I did finish phase 1 by September 1st, and it's been less than 2 weeks since I started phase 2. Phase 2 being the Terraform and the release process for my Docker image. So we'll take a look at the Docker a minute. Yeah, I'll do that right now. Switch down here, Dockerfile. Okay, so you put this in production mode. Make sure that I'm grabbing the package first. I'm changing the ownership to node. I'm not using the root user when I'm running this package. And I'm only running production parts of the npm package. And then I'm again changing the ownership to node and copying everything from the current directory into the app directory on the container. I'm using port 80, standard HTTP. And then I have a health check, which it turns out we're not using, but we could. And I make sure we're using node when I'm running this. There's a dumb init. You can look this up. This is really handy for making sure that you have some isolation between your process and the system. And then I'm running node for app.js. We've looked at this app.js file before in previous videos, and that's it. It's just not that complicated. Oh, I forgot to mention, I did start with Bullseye Slim. I looked that up as being something that I recommend for Node.js hosting. So what does Terraform look like? This is what it is. So you got resources, you've got variables, you've got data that you, again, look it up. I'm not going to teach Terraform right now. It's too much. But just so you kind of see what it kind of looks like, you've got some variables that are passed in. Don't get me started on CIDRs. So you're going to have, so here's the VPC, the Internet Gateway, some route tables, blah, 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 340 lines or so, down to the IAM role policy attachments to go onto your roles. Boy, there's a lot there, right? Yeah. So again, I can't teach that in a short period of time, but there's definitely some courses out there. And again, I recommend just muddle through it. Just try some things. There's some starter courses on this, and it'll be useful for your cloud computing life. And if you don't want to do it that way, you can do it manually. Just come in here, go into the console, and just start creating things manually. That's not a problem. For me, I don't like paying for things when I'm not using them. And right now, I'm not going to be using this for a while. I just want to make sure I had it all set up so that when I'm ready to use it, it's ready to go. All right. Well, how fun. So next, we're going to get back into doing some more code design.